So good evening everyone. So today we will be discussing structure of atom. See, whatever the session I am going to do now, this is equally important for all the NEET and EAPCET aspirants, okay, even for JEE aspirants also. See, here when it comes to structure of atom, what are the concepts we required, I have already covered in this channel itself, okay. Now in this session we will be solving questions by quick revising the topics, so that it will be more effective and more productive it will be, okay. So the first question here, very basic question I will show you first, okay. We'll start from very scratch here, okay. First of all, try to answer me this: how can you calculate energy for a given photon of wavelength of 3000 and 6000 angstroms? So what is the formula to be used here? What is the relation between wavelength and energy? Yeah, energy is equals to, or energy is directly proportional to frequency. So from here I can use h nu, okay. So this is a very basic formula to be known in order to start structure of atom, okay. Like this we will be having all the basic formulas and to the advanced level, whatever the content we require, okay, right. So now what is h here? Planck's constant. Now what is its value we have? See, for they are saying for a given photon, it means one photon. If there are n photons, you should write it as nh nu, okay. For Avogadro number of photons, it means n here it should become Avogadro number, that's it. If I say 1 mole of photon means what should be the n value? 1 mole of photon means how many photons will be there? Avogadro number of photons. Here you should take Avogadro number like that. So here they are saying 1 photon, you just take it as 1 into Planck's like here 6.6 10 power minus 34 joule second. Frequency they haven't given. Now in the place of frequency I can write E is equals to hc by lambda. So c is what? Speed of light, meter per second, okay. And in the denominator it should be lambda. So what is the lambda value they have mentioned? 3000 angstrom, that's it, 3000 angstrom, okay. See, they have mentioned here meters now. So we need to convert this angstrom into meters, okay. So 1 angstrom is how many meters? 10 power minus 10 meters, okay. So here if you observe second inverse, meter, okay. Is this clear? Now answer for energy should be in joules or calories or ergs, like that we need to get, okay. So it means we are only having joules, means yeah, we are doing it properly, okay. So now what I can remove here? 3 zeros, so that it becomes 10 power 5, okay. This is 10, this means 10 power minus 24, okay. Minus 24 means minus 24 plus 5 minus 19, so 10 power minus 19 it is, and units we have is joule, okay. Then next 3, okay. So that what we have? 6.6 into 10 power minus 19 joules, okay. So this is the energy. So in the same way, can you do it for the other one? What is the energy value, you tell me, for the other one?
3 into 10 power minus 19.
Huh?
3.3 into 10 power minus 19.
Yeah. So just tell me what I should use. Yeah, in the place of
3000.
I should insert 6000. So if it is 3000, we got this. 6000 means by 2. So this number by 2 means for second question your answer will be 3.3 into 10 power minus 19 joules. Okay, that's it. 19 joules. That's it. This is your answer. Okay, this is very basic now. You got, I hope. The next one here, let's move little more deeper. So that is, look at this. What they are asking? Calculate the frequency and wavelength of a photon with energy 3.98 into 10 power minus 15 joules. What to do here, tell me?
Frequency
Yeah.
H mu.
Yeah, frequency. Frequency, let us indicate with the frequency, nu, lambda, wavelength. Okay. Now they are asking with energy, that much energy is there, we need to give respect to frequency. So E is equals to h nu. So E is equals to, I want frequency, so simply I can write nu frequency equals E by h. Okay, E is 3.98, let us take it as 4, yeah, because large difference is there in the options, into 10 power minus 15 joules divided by h. So what is h here? Planck's constant. So how much it is? 6.6 into 10 power minus 34 joule second. What is the units for frequency? Second inverse. Hertz or second inverse? Yes. Joule if we remove, we are going to remain with second in the denominator, that is second inverse only. Okay. Now here, how much it is? Minus 34 means 24, again 19. Yeah. So this will be 10 power plus 19 will get here. That's it now. And 2, 3.3 and here it is 2. So I am writing this as 18 so that I can place here 0. So on 20 by 3.3. So in 3.3 into what number will get?
Approximately
6. 6 3 is 18. 3.3 into 6 gives you almost 20 only. Okay. So how much I can say here? So what is the frequency I got? 6 into 10 power 18 second inverse is a unit, frequency value here. Yes, first option we have exactly the same value, right. So now they are asking what is its wavelength. So how can you do this wavelength? C by lambda. Yeah, so just do it and tell me what's your answer. Those who are in the live session, who are watching it live, please respond in the comment box. Even if it is wrong, no issue, you please mention your answer. That's it. Just involvement in the class is required here.
0.5 into 10 power minus 10, which is 0.5 angstrom.
Yes, 0.5 angstrom. How can we do this? Lambda means C by see, frequency is what? Frequency means C by lambda. So lambda can be written as C by nu. So this is 3 into 10 power 8 meter per second and frequency is 6 into 10 power 18 second inverse. So second inverse removed. So this will be 1 by 2. So this will be 10 power minus 10. Okay, so 1 by 2 means 0.5 into 10 power minus 10 meters we got. So 10 power minus 10 is nothing but angstrom. 1 angstrom equals to 10 power minus 10 meter. So it is 0.5 angstrom. So first option is your perfect answer for the discussion. The next question here, it is saying about work function of metal, all threshold frequency is this much. See, work function, where do you hear this word? Photoelectric effect. So what is this photoelectric effect? See, I do not want to discuss completely whatever the things there we use, but I will give you the some clarity here. Yeah, first option right. Okay, so first of all, if this is a metal surface, what happens? Some energy will incident, that is what incident energy we are saying. So incident energy let us indicate with E. Now what happens? This metal surface contains some electrons, right now metal atoms contain electrons. So when this is suitable amount of energy incident on this, ejection of electron takes place. Okay, now this ejection of electron, see here for example this is the metal surface holding one electron. See, in order to eject this electron, I need to use some energy. So that minimum energy that is required to eject this electron is called threshold energy, or the frequency called a threshold frequency. Let us indicate with pi. That is called a work function or threshold energy here. Okay, what do we mean by work function? The minimum energy required to eject the electron from surface of the metal during this photoelectric process. Okay, now for example, for this threshold energy I am saying this has some 5 electron volt is required, but I am supplying some 10 electron volt energy I am supplying, or let us say some 9 electron volt energy I am supplying. Now what happens? Out of this 9 electron volt, only 5 electron volt of energy is used by this electron. Okay, see what I am saying, the photon falling here have 9 electron volt. Okay, out of that, see, one photon will eject one electron. Remember, if it is having 10 joules, one photon have some energy of 10 joules. It doesn't mean it will eject 2 electrons. No, one photon will eject one electron. Now that electron is ejected now, so how much energy is required? 5 joules. How much I am supplying? 9. So now the extra 4 electron volt of energy is there now. So that is utilized by this ejected electron. Okay, now this electron will consume that 4 electron volts of energy, and that will convert into its kinetic energy. Now the energy supplied, that is energy supplied, is converting into two forms. One is a work function, that is threshold energy, and that is kinetic energy of photoelectron. Is this clear? See, work function is also nothing but energy only, no? So I am writing this as h nu naught, and this supplied energy as h nu, okay, plus kinetic energy means half mv square. So I can write h nu equals to h nu naught plus half mv square. This is very basic, I hope everyone got. Okay, now in the question what they are saying, what is the work function of the metal whose threshold frequency is this much. It means they are asking us to calculate work function. See, work function formula, here I used phi symbol, here they are using omega naught or w. Okay, so this is nothing but, this is also energy only now, that is E naught I can say. Okay, so this is nothing but a h nu naught. Okay, so that's it, frequency we got here. So work function will be how much now? 6.6, this Planck's constant number into 5.2 into 10 power 14 second inverse seconds cancel, so you will get some answer. Okay, that is in joules, so that will be your answer. Okay, I hope up to here it is clear. This is very basic question that everyone should know. Okay, right, let us go for little more tricky way. The question here we have, yes, try to get the answer for this.
B.
Yeah, how can you say that it is B?
This also C by lambda we have.
Yes, B is correct answer. Yeah, one straight, everyone. So what is the formula we should just now we discussed?
HC by
H,
lambda. Hnu we discussed.
h nu equals to h nu naught plus
Half mv.
half kinetic energy is half
Half
mv square. Okay, so now what they are saying?
Of frequency we should write C by lambda.
Yeah, see now what I am doing, they are asking lambda naught and lambda are the respectively threshold wavelength and wavelength of incident light. The velocity of photoelectron ejected from the metal surface is, it means this V they are asking. So now what we can do here, see I am converting this into hc by lambda, this is hc by lambda naught. Okay, now this is half mv square. See, photoelectric effect, why I am discussing here, it is equally important for your physics also, right? We can expect a question either from physics or chemistry. So at least you know, like you need to know this concept, okay, perfectly. Okay, so now here I want this new frequency, not the velocity I want, so I need to send all this side. See what I am doing, I am dividing this with hc. So what happens otherwise, hc I am taking common here, 1 by lambda minus 1 by lambda naught is equals to half mv square. Can we write it like this? Yeah, send that to this side, 2hc by m 1 by lambda minus 1 by this much, which is equals to v square. And after this what we can do, they are asking only velocity. Yeah, so I can write v is equals to, right, root over c by m. So this one there is no option like this, so what we can do is take the LCM of these two, lambda naught into lambda, that is lambda naught minus lambda. So we have option B in this manner, right? So that is our answer. Okay, this is about again photoelectric effect only. Okay, let's move forward. Now let's see questions from Bohr model. Okay, so before that, just what are the formulas to be remembered from Bohr model? One is radius formula. What is the radius formula we have? Z. Radius of an electron revolving in an nth orbit equals to 0.529 n square by z angstroms. This is one formula to be remembered. Okay, and the next one is from velocity. So what is that velocity formula? Velocity 2.18 into 10 power 6 z by n meter per second. Velocity, so meter per second. This is second formula to be remembered. And the next one here, energy. Please make a note of all these formulas, energies in different units. Okay, first one is this formula, energy is equals to minus 13.6 z square by n square electron volt per atom. This is very very important formula. And the next formula is this one, minus 2.18 into 10 power minus 18 minus, you can remember in this way, okay, z squared by n square joule per atom. These are the two important formulas. Okay, along with this you just remember the other formula also which I have mentioned. Okay, next, this is the energy difference. Now for example, what is the formula we have used? What is the formula we have used? Electron volt, you tell me. E is equals to minus 13.6 z square by n square electron volt per atom I discussed. Okay, let us say electron is present in hydrogen atom. Which atom? Hydrogen atom. Hydrogen atom first orbit. So n value is 1, z value also 1. So here what happens? Minus 13.6 electron volt per atom. So this energy is how much energy we have? If this is the nucleus, these are the orbits we can say like this. So now if electron is present in this first Bohr orbit, okay, see this is the nucleus, this is completely nucleus. Now if electron is present in the first Bohr orbit of hydrogen, so how much energy it has? So now you might be having, sir, what is this minus? See, for example, electron is existing independently without any attractions or repulsions. Okay, let us say its energy is 0. Okay, now we know higher the energy, lower is the stability. It means lower is the energy of that species, greater is the stability of that species, right? So now if an electron is present independently, its energy, let us say 0 state. Now if it is moving closer to the nucleus, now that is what we are putting the electron at the first orbit of atom. Now how much energy is lowered? When I compare with the independent electron, so minus 13.6 electron volt of energy is lowered. Okay, it means this is the most stable state of that system. Okay, now what I am doing is, if I bring this electron close to the nucleus, stability of that system is increases. Now I am moving that electron far from the nucleus. Let us take the electron from first orbit to second orbit. Okay, now when it comes to second orbit, what happens to energy? Just check. Minus 13.6 z square hydrogen atom 1, n square is 2 square, that is 4 electron volt per atom. Now minus 13.6 by 4 means so this is 3.4. So see, this is just minus 3.4 electron volt. So this number is bigger or this number is bigger? See, minus 3.4 is bigger number now. So it means as we are moving electron far from the nucleus, its energy increases. Stability, yeah. So now if you observe the first state energy is minus 13.6. So second state energy is minus 3.4. So as we move away, like n state is 3. So its energy is how much? Minus 1.51. Like that I am going up to infinity we have reached. Now what is the n value I am saying? Something by infinity will be 0. It means this indicates, what is this indicating? We are keeping electron at an infinite distance from the nucleus. That is, electron is now existing independent. That energy is considered to be 0 state. Okay, 0. Is this clear? Okay. So now they will ask you, just observe here what you are seeing here. If I compare the energy difference from 1 and 2, how much energy difference is there? So first one is minus 13.6, second one is this much. So difference of this is how much? 10.2 electron volt. Okay, do you got? We have 10.2 electron volt of difference. But if I want to compare between 2, 3, this is just 1.89. If I compare 4, 3, what you are seeing, as we move away from the nucleus, the energy of that electron increases. Energy difference is more at the beginning, at the closer to the nucleus. As n number increases, energy difference decreases. This is one of the very important factor. We can see some questions also. Okay. Now tell me. This is one thing. It's over now. Now one more thing I just want to discuss is. see, they will say for which electronic transition energy difference is more.
First ground state to second.
Let me complete the questions again. Okay, first question, let me complete the question once again. Energy difference delta E is more in which are the following case. Okay, first one is N1 equals to 1, 2, N2 is some 2, N2 is 2, is some 3. Tell me here, A, B, C, let us say 2, 3. So where do you see greater energy difference? Third one. Do you got what I am saying?
Yes.
See, this is this much only energy difference. Here this much, here this much. Do you got this? So let us keep this a question aside. Okay, this is one type of question, and the second type of question here is delta E is more in which are the following case? So first one is here is between N1 equals to 1 to 2, second one N2, N1 is 2, N2 is 3, N1 is 3, 2, N2 is 4. Yes, tell me from this. Do you got the difference? This is a different manner, this is again different manner. See, where do we see the maximum difference? Second state energy state to first state, or first excited state to ground state. Okay, ground state means n equals to 1. First excited state means n equals to 2. Okay, so where do we see the maximum difference?
In first
So that is what the second question says. Do you got the difference in the questions? Right. So the next, something called spectral lines are there. I hope you know. For example, hydrogen atom, if we consider, if any higher energy state to ground state, that line falls into Lyman series, in which it will be
Lyman series.
So now what are the lines possible for Lyman series, you tell me? Lyman series lines. So N1 should be 1. This should be fixed. No, N2 can be any higher energy state not equals greater than 1. Okay, so now it can be N2 can be 2, 3, 4, 5, so on, infinite we can take. Okay, so now what is the closest line we have? 2 to 1. This is the first line of the Lyman series. Now they will ask what is the H alpha line of Lyman series? 2 to 1. Okay, so this is H alpha line or H first line of Lyman series. Now what is the H beta line? 3 to 1. Do you got what I am asking? So this is second line or H beta line. Okay, H beta line. H gamma line means or H third line. Okay, so now H infinite line means now what are the series limits for Lyman series? Series limits means first line and last line, that is H alpha line and H infinite. That's it. Okay, these are series limits. Now what are the series limit numbers? This is 2 to infinite, 2 to 1, and this is infinite to 1. These are the series limits to be remembered here. Okay, do you got what I am saying here? These are also important factors. Next, now one more thing is they will ask, what are the other series lines we have? Lyman, Balmer, Paschen, Brackett, Fun series, and Hamfari last. Okay, so these are the lines we have. Now there is something called Rydberg's equation, that is to calculate the wave number or wavelength. Okay, 1 by lambda I can write. 1 by lambda is wavelength and lambda is wavelength. 1 by lambda is called wave number. So this is equals to RH Z square 1 by N1 square minus 1 by N2 square. Okay, so now RH value you can just simply remember it as 1.1 into 10 power 5 centimeter inverse. Okay, into Z indicates atomic number. Okay, 1 by N1 square minus 1 by N2 square. Always N2 should be greater than N1. Okay, right, this is the thing. Or N initial, N final, you can remember. N1, N2 means. Okay, this is the equation to be remembered here. Next, now they will ask for the first question. Let us see this question. This first question, forgot about second one now. First question I am taking. What is the energy, like energy difference is more in which case you are saying?
1 to 4.
1 to 4. 1 to 4. It means 4 to 1. Okay. Now maximum, lambda max absorbed in which case for these three options? Tell me.
1 to 2, like 2 to 1.
Yeah. So if energy is more, like what is the relation between energy and lambda? Inversely proportional. So if you have maximum difference,
Less wavelength.
maximum difference, that is maximum energy, minimum wavelength, minimum wavelength. So you need to remember this. Now tell me, they will ask you one question. For Lyman series, what is the maximum energy difference lines?
2 to 1. Maximum energy.
Like this kind of model I am saying. Na? Now tell me, from infinite to infinite to 1, that is a maximum line. Okay, that is a maximum line we will get. Energy is max from like 2 to 1 they will give, infinite to 1 they will give, okay, or 3 to 1 they will give. So which is having maximum? Yeah, infinite to 1. So if I say A, B, C, so which is maximum?
C.
So lambda max is C option. If I ask for energy max is this one. Lambda max if I ask?
2 to 1.
2 to 1. This is B. Do you got what we are solving here? So most of the questions are on this thing. Okay. Now what we need to do? We need to calculate. Now they won't ask like this only. Like this is the main concept to be remembered. Now they will ask us to substitute those values here and give exact calculation with 4 options. Okay. This is a model question we can see. Okay. Next one is not only Lyman, they may ask it for Balmer. What is a H alpha values, line values for Balmer series?
H alpha 3 to 2.
Yes, N2 should be 3, N1 should be 2. This is Lyman Balmer. Balmer alpha line, first line of Balmer series. So all Balmer series lines will fall in
Second.
that is visible region.
Region.
Okay, let me take that. If here, this is again important table for NEET exam point of view and the thing. So Lyman series, any higher energy state to first UV. For Balmer series, any higher energy level to that will be visible. For any higher energy state to third comes in patchen, that is in so first one is UV, next one is visible, remaining are IR you can remember. This is near IR, mid IR, far IR you can remember. So bracket, mid IR, any number higher energy state to 4, fund, any higher energy to 5, like that you can remember. Hamfare, any higher energy state to 6. Okay. Next, this is done. Now let's solve some questions here. Now look at this, what they are saying. Statement 1 says, tell me what they are saying in the first question. The question says, statement 1, the Balmer spectral line for hydrogen atom with lowest energy is located at this much value they are saying. Is this correct or not? We need to verify first statement. Yeah, first lowest energy means what is the transition we discussed?
Like 2 to 3.
Yeah, Lyman, Balmer. So Balmer means N1 should be 2.
And N2 should be 3.
N2 should be anything from 3 to infinite, but lowest energy difference means 3 only. So this is the least energy difference. You got the concept here, right? So now take the formula 1 by lambda equals to RH Z square, that is hydrogen atom, that is 1. 1 square is 1. And 1 by N1 square, 2 square 4. 1 by N2 square 9. Okay, 1 by lambda is equals to RH. 9 minus 4 is 5 by 4 into 9 is 36. So lambda can be 36 by 5 R 5 R H. Yeah. So what they are asking? Energy. They are asking about energy now. This is wavelength calculation. The inverse of this is nothing but energy. Okay, this is for wavelength we have taken. No issues. So energy difference if I ask, you just take same thing. RH Z square 1 by N1 square minus 1 by N2 square. Okay, here you can substitute RH as it is. Z square is 1. This is 5 by 36. Yeah, we got same thing now. Yeah. So this is perfect. Statement 1 is perfectly correct. Now next statement is about black body radiation. See, when the temperature of black body increases, the maxima of curve, that is wavelength, shift shorter wavelength. Will you agree with this? Yeah. So how the graph will be? Like lambda here. Okay. So we'll be seeing something like this. Something like this. Okay, let me write little bigger. Like these. Like these. Yeah. So if I say this is T1, this is T2. So which is higher temperature? Tell me. T1 here is higher than T2. In case of wavelength, if it is frequency, T2 is higher than T1. So this is the difference you should remember. Okay, that's it. Okay, I think in physics you will be studying in more with using Wien's displacement law and all. But anyways, you got the concept now. That's it. So both statement 1 and 2 are true. So which one?
C.
Yeah, both statement 1 and 2 are true. That's it. Next. Tell me for this, how can you solve? A particular radio station, a station of All India Radio, New Delhi, broadcast on a frequency of that much. The wavelength, frequency given, wavelength of electromagnetic radiation emitted by this transmitter. What to do? We already did this model. Yeah, you just take the values and try to calculate. See, kilo means you should convert into what is mean by kilo here? 10 power 3 hertz. Hertz means you can say second inverse also. Okay, speed of light meter per second is there. Second inverse, hertz cancel. You will get answer in meters. Okay. If you simplify using this, 219.3 will be your answer. Okay, right. Next, this one you try to explain me how can you solve. Yeah, lambda 1 equals to
2 lambda 2.
So how to do this? Tell me.
Energy is inversely proportional to
Yeah.
wavelength. 25 by 50 is equals to lambda 2 by lambda 1.
Perfect. See, they are saying energy is of E1, E2 are given like that. The relation between their wavelengths lambda 1 and lambda 2 will be. See, lambda 1 by lambda 2. Okay, lambda 1 means hc by lambda 1 and lambda 2 means hc by lambda 2. So I can remove these constants. So lambda 2 by lambda 1. So now what are the energies they have mentioned here?
25 by 50.
E1 is 25, E2 is 50. Electron volt electrons. So 1 by 2. So what I can say?
Lambda 1 is equals to 2 lambda 2.
So 1 by 2 is equals to lambda 2 by lambda 1. So lambda 1 equals to 2 lambda 2. So where do we have? That is your answer. Okay. See, all questions that I am showing you here are PYQs only. Okay. Yeah. Let's solve this question. What will be the longest wavelength line in Balmer series. This is one of the important model now. Try it once. I given the required content already just now in the discussion. Yeah, so what to do, tell me? So what is the longest wavelength? Yes, tell me, longest wavelength, least energy difference. Least energy difference for Balmer. See, Lyman, Balmer. So second one, so N1 should be 2 and N2 should be how much? It should be 3 or infinite? 3. I already discussed now. So energy difference should be minimum. That's why for this clarity only I have discussed the previous one. Okay, do you got this? This is the maximum lambda max. Okay, so now that's it. We got the answer. So 1 by lambda is equals to RH Z square. Which one is that? Hydrogen atom. If they are not mentioned, you just take it as hydrogen atom. 1 by N1 square minus 1 by N2 square. That's it. So this one has 1.1 into 10 power 5 centimeter inverse. This one Z square is 1. This one is how much? 2 square is 4. So 1 by 4, 1 by 9. So 36, 5 here, 36 here. Perfect. This is 1 by lambda. Now they are asking lambda can be inverse of this. So it means what I can write? 36 by 5 into here it is 1.1 right now into 10 power 5 10 power minus 5 and this becomes centimeters. Okay, so now in the place of centimeters what I required? Nanometers. Okay, so 1 centimeter 10 power 7 nanometers. Okay, so 36 into 10 power minus 5 into 10 power 7 nanometers by 1.1. Okay, let us write this as it is. Anyways, we have large difference, we will get the answer, no worries. Okay, this is how many times? 10 power 2. Okay, so now how much it will be? 6. Let us say this is 5.5, let us say. Now tell me, 5.5 means?
It will be approximately 6 times.
5, 6 is 30. Yeah. 5.5, 6 you just check. 0, 3, 30, 33. Okay, so 36 means 30. So this is the nearest option we have 6. Okay, so where do we have starting with 6? Only B. So it's very easy to conclude. Yeah, second option will be your perfect answer for the discussion. Okay, that's it. Next, tell me for this. Tell me, energy of an electron in the ground state for helium ion is? Helium plus ion is minus x joules. Then what? Then that for an electron in second state of beryllium, what to do? What is the energy formula we have?
13.6.
Yeah. So even no need of taking the constant values also. See, they are saying in joules. What is the formula in joules? 2.18 into 10 power minus 18, 10 power z square by so no need of taking all those, you just take the relation here. This is z square by n square. Okay, right. After this they are saying for electron of ground state for helium, that is H1 of helium plus by H or next one is H2 of beryllium plus 3. That's it. These are the two things. Proportionality means we can remove here as a constant. Okay. So for this one, what is the Z for helium? Hydrogen helium 2 square, and N1 is N is 1 here. So it is 1 square 1. Next for this Z is how much? Hydrogen helium beryllium 4 now. So 4 square 16 I can write here, and this one is N2 square means 4. So 2 square here also 2 square, that is 4. 4 is 16, so removed. So what is the value they have mentioned for helium? Minus x. So for this one also it becomes minus x. So if this value is minus x, if I send this here, that is also minus x. Okay. So now remember, the model questions here we are seeing in the exam is difference in wavelength. The previous question that we did, lambda max or energy minimum, this wavelength question, this Rydberg equation questions, this is one type of question. Next one here is comparing energies, E1 by E2 type questions, and R1 by R2, R like radius of two things. If radius of one orbit atoms is x, then for the R2 is how much? So for some other element or something like that. Okay, these are the models we are expecting, and the next we have some other model. We'll see. First of all, let's finish with this. Yeah. So just read this once. Tell me what will be your answer. So the above question has answer C. For the other question, you tell me. Yeah, if the radius of second Bohr orbit of helium ion is this much, 105.8 picometers. So what are the radius of third Bohr orbit of lithium plus 2?
158.7.
Yeah, 158.7. How to do this? It's very easy again. So R2 of helium plus R3 of lithium plus 2. This is radius is directly proportional to n square, inversely proportional to z. So I can say here n square for helium is 2 square 4, and z value for helium is 2. Okay, for this it is n square is 3 square 9. What? Hydrogen, helium, n value is how much? 2 they have mentioned, second Bohr orbit. So it is 2 square 4. Z is how much for helium? 2. Okay, and for lithium it is 3, n square is 3 square 9, Z is 3. Okay, that's it. Up to here it is clear. So this one is 3 times. Okay, and what about this value mentioned? 105.8. Okay, and this is 2 times. So R3 of Li plus 2 is 3 into 105.8 by 2. So upon simplification, how much we got? 158.7. Okay, that's it. Next, tell me for this. In a Bohr's model of atom, when an electron jumps from 1 to 3, how much energy will be emitted or absorbed? Again, easy it is. Tell me, how can we do this? E is equals to joules now. Joules. So what is the relation between joules and eggs? 1 joule 10 power 7 eggs. Can you use this and you can get this? So you can use energy in terms of joules formula is there now? Yeah, wherever you have joules, you can multiply that with 10 power 7. So once solve this, once solve and tell me once fast. So what is the energy difference? 2.18 into 10 power minus 18 z square 1 by n1 square minus 1 by n2 square. Okay, that's it. So tell me what the next step here. 2.18 into 10 power minus 18. This is in joules. Okay. So z square is 1 for an atom electron jumps from. Okay. The next 1 by n1. n1 is how much? 1. This is 9. n2 is 3, 9. Okay. So it will be 2.18 into 10 power minus 18 into 9 by 9 minus 1 by 9 joules. So 2.18 into 10 power minus 18 into 8 by 9 joules. Okay.
0.193 into 10 power minus 10.
Yeah. So this one I can write 10 power 7 ergs. So it means 10 power minus 11. The next.
It will be simplified as 1.9.
They are asking in terms of 10 power minus 10, 11. Okay, fine. So 2.18 into 8 by 9 into 10 power minus 11 erg. So how can we simplify this?
So it will be around 1.92.
This one?
Yes, the whole.
Yeah. So 1.92 into 10 power
11.
minus 11 ergs.
Yes, then it will be 0.192 into
Yeah. So you can write 0.192 into 10 power
minus 10.
minus 10 ergs. Okay, that's it. Okay. So the next question here. This one you tell me. The hydrogen atom first energy of first excited state is this much. Okay. Then they are asking find out the kinetic energy of the object. So what is the relation between total energy and kinetic energy? Energy, what is the total energy? Minus 13.6 we are taking now. Here we are taking with minus symbol. You just take same values with the plus symbol. Okay. So now it is in electron volt. So kinetic energy can be plus 13 yeah, that's it, 13.6 into n square by z square by n square.
Given as -3.4 for the same orbit, so it will be plus 3.4.
Yeah, that's it. See, for the first excited state, energy is this much. It means, so the same energy will be required, I mean, kinetic energy. Okay, so that's it. Otherwise, you can use this formula z square by n square. So here you put the values. They are saying first excited state. So n value is how much? First excited means 2. First ground state means n equals to 1. First excited state means 2. So here it is 2 square 4, 1 hydrogen atom, 13.6. This will be 3.4. So this is the kinetic energy. Okay. That's it. Next. This one. From where it is, tell me? Yes.
Delta x into delta p is equals to h by 4 pi.
What is that?
Delta x into delta p.
If the uncertainty in the position and momentum are equal, then uncertainty in the velocity. Yeah, how do we do this? What is the formula for uncertainty? HUP. Delta and error in the position, error in the momentum equal or greater than h by 4 pi. So simplifying now, let us take this as equal. Okay. So now what they are saying, uncertainty in position, momentum are equal and asking for velocity. See, momentum and these are equal means let us say momentum square. Why? Because in momentum only we will get velocity.
So it will be 1 by 2m root over
H by 4 pi. So this will be m delta v square, mass into velocity change, 4 pi. Next,
we have to substitute this.
delta v h by 4 pi m square. This square becomes root here. Okay. Next. So what I can write, 2 square this one. 4 means 2 square, so 2 m root over h by pi. That's it. So we have B. That's it. This is your answer for the question. Next, this one you tell me from where it is again. See, 0.66. No, 0.66 kg of ball moving with a speed this much, associated wavelength, mass, wavelength. What is the relation? De-Broglie equation, lambda equals to h by mv. Yeah. So now lambda equals to, now what they are asking, wavelength, no? 6.6 10 power minus 34 joule second. Mass is how much? 0.66 kg. Velocity is how much? 100 meter per second. See, joules can be written as kg meter square second inverse square. Okay, so kg you can remove, meter square you can remove. Next second, all second is removed. So we are getting answer in terms of meters now. Yeah. So this will be how many times? This is 10 times.
Yes.
Okay. Next, this is removed. So we'll get 1 into 10 power minus 35 meters. That's it. Yeah. We have option C is your answer for the discussion. Next, one question from quantum numbers. Yeah, remaining from quantum related questions we will discuss in the next session. Yeah, tell me here. The quantum numbers of 4 electrons are given below. The correct decreasing order of energy of these electrons is. Tell me what to check. Remember, I will tell you two things. When in the question they are just mentioned a question without saying for single electron system, means that question is related to multi-electron system. Okay, so there is two things here, two systems are there. Single electron system, it means something like hydrogen atom or helium ion or lithium plus 2 ion, like the Bohr model limitations are there, na, those things. Okay, and the next one is multi-electron system. Okay, multi-electron system means what? Helium atom, not ion here. Beryllium atom, like all carbon, nitrogen, all the things. So here when they say single electron, energy depends only on n value. Only on n value check. Higher the n value, higher is the energy. So for multi-electron system, it depends on n plus L value. Okay, so now here what to consider now? N plus L here. Okay, so this is 6, here it is 5, 5, 4. Yeah, tell me now. Highest energy is for 1. Between these two, how can you say? If n plus L is same, consider higher the n value, higher is the energy. Yeah, so 1, 3, 1, 3, 2, 4. So B. Okay, that's it. Okay, remaining questions we will be discussing in the next session. But anyways, please cover complete structure of atom by tomorrow. We'll discuss all the questions from structure of atom. Then we'll move further some basic concepts of chemistry, that is mole concept. That's it. Okay, fine. Are question enduku raledra? Adedi